Okay, last one, question 4. So this is the genetics cross. Lovely sweet peas, they're my favourite. I love sweet peas. Not very good at growing them, but it smells delicious. So, number of different colours including white and purple. I'm assuming that shows white and purple ones, but hey, who knows. Pollen was transferred from the anthers of white flowers onto the stigmas of purple flowers, so we're doing a white-purple cross. And we're getting, some plants produce purple and some produce white, so we're getting both in the offspring. And we've got 2 hypotheses to explain this result. The first hypothesis is that the purple is dominant and it's a single gene. Construct a genetic diagram to show the genotypes and phenotypes of the parents of this cross. We're assuming that I don't want to use purple, I'm going to use A. Oh, it says let's use letters big A and little a. So our first cross is white crossed with purple, and our white, if purple's dominant, has got to be little a, and our purple, in order to get some white offspring then, has got to have the dominant allele for purple and a recessive one to pass on to make a white offspring. So our gametes, I'm just going to put that in the middle so I don't get confused. So we get a 1-to-1 ratio of white to purple, or purple to white. There, here comes the rub. So now obviously we're going to do a lovely chi-squared test. So first of all, writing a null hypothesis. So null hypothesis is always there is no, and you must put this word significant in. Because obviously there is a difference, but it's how to the point that difference is. No significant difference between observed and expected numbers. So our observed numbers are 32 and 18, and we want to know, we were expecting it to be 1-to-1, weren't we? We were expecting half of them to be purple and half of them to be white. So trusty calculator out. 32 plus 18 equals 50. So I can even do that in my head. So what I would have expected was 25 of each. Observed minus expected, that's 7. That's going to be minus 7. Square it, 49, 49. I'm doing well in my head, aren't I? So we're going to take that number and divide it by expected. So 49 divided by 25, which I can't do in my head, 1.96. And 49 divided by 25, it's going to be the same, isn't it? 1.96, and then I need to add those two together. So 1.96, 3.92. That looks okay. So use the table, chi-squared numbers. There we go. To state whether you would accept or reject the null hypothesis stated in A2, explain your answer. So I'm to look down the 0.05 column. I've got 2 phenotypes, 2 take 1, 1 degree of freedom, give me a critical value of 3.84. Now I would always do that, but then you actually need to state it. You actually need to write it down. Don't rely on your examiner being either able to see this or knowing why you've circled that number. So the critical value is 3 point, oh no, that's my answer, 3.84. Yeah, do be careful there. The chi-squared value is bigger than the critical value at p equals 0.05 with 1 degree of freedom. And again, when you're answering these chi-squared questions, t-test questions, you know, just give them the whole lot. Yeah, you tell them you know what the critical value is, tell them which column you've used, tell them which row you've looked along. So what does this mean? This means the null hypothesis, that there's no difference, is rejected. What does that mean? There is a significant difference between the expected and observed ratios. So what you're saying is it's really not likely that it's a straight dominance recessive thing. Oh, turning over. Oh, there's more. So we've got now a second hypothesis. Second hypothesis is that the purple variety is produced by an interaction between two unlinked genes. So this means that we're going to get that, we're going to need to FOIL it. Presence of at least one dominant allele for both genes, so anything that is A, B is going to give purple. The plant is homozygous recessive for that, doesn't matter what's there, doesn't matter, they could have big B's or little b's, will give white. And for either gene, so there could be big A, yeah, little b, and that will also give white, and then of course the little a, little b will definitely. So, given that the genotype of the purple flower is big A, big B, little b, and the genotype of the white flower is little a, big B, little b, the gametes for the white, so this one's been done, that one's been foiled for you. So, foiling. Big A, big B, little b. First, outside, inside, last. Now I need to fill it in, so that's big A, big B, big B. That's going to be purple, one of those. Big A, big B, little b, purple. Big A, big B, purple. Big A, little b, little b, white. Got 3 of those. Not clear. Little a, big B, be white. Little a, big B, little b, white. Little a, big B, white. Little a, little b, white. So I've got a 3 to 5 ratio. That's weird, isn't it? 3 purple to 5 white. I'm just going to check that again. So, reading my information again. One dominant allele for both genes, so anything with a big A and a big B, big A, big B, big A, big B. not, big A, big A, not. Oh, so I am right, even though it looks weird. So, the value of the chi-squared was calculated at 0.44 using the data. So, that's going to be less than 3.8. Just reminded myself, I've got a critical value of 3.84. So, the chi-squared value is less than the critical 3.84. So there is no significant, we've not got any data, have we? So no significant difference between observed and expected, except, or again, hypothesis 2. Is correct, more likely to be correct. Let's use their wording, more likely to be correct. Okay, explain how a cross between two white-flowered parents which produced purple-flowered offspring would confirm that hypothesis 2 is correct. Oh my word. So, in hypothesis 1, start with the easy one, the cross would be little a times little a. All flowers would be white. In hypothesis 2, how could I get some purple flowers? So if I crossed, let's look at my white flowers genotypes. So if I cross that with that, or that with that, I'd have the possibility of combining a big A allele with a big B allele, wouldn't I? So I'd have little a, big B alleles, little a, little b, big A, little b. So yes, I could do that. So with hypothesis 2, some white-flowered plants could have capital A allele and some capital B. So when crossed, offspring, it seems a bit wordy this, but anyway, could inherit big A and B alleles. Okay. Oh, to be purple. Let's just put the phenotype in. Okay, job's good. And now, obviously, in an exam, I might get away with that, and I might get away with that, but I probably wouldn't risk it, and I'd probably put back page and go to the back page and write a bit more. Just a warning.